So if you could use a graphing calculator, you probably wouldn't be watching the video for this problem. So let's graph this rational function using other methods. The first thing we want to consider is asymptotes, those things where a graph gets infinitely close but never touches something. Like this, it demonstrates a vertical and a horizontal asymptote because it gets infinitely close to this line but never touches. It gets infinitely close to an imaginary line here but never touches. So horizontal asymptotes, we'll start finding that. There's three basic rules you can use. Whoop, this is supposed to be down here. If the power is bigger in the top, in this case, the power on the top is the first power. The power on the bottom, if you were to expand this, would be x to the second. So if the power is bigger than the top, then there's no horizontal asymptote. But if the power is bigger in the bottom, which is the case here, x to the first in the top, x to the second in the bottom, then the asymptote is always y equals 0. In other words, it gets infinitely close but doesn't touch the x-axis as we go off to infinity. And just in case you need to know, if the powers are equal, it's just a ratio of the leading coefficients of the top and the bottom. So this one, y equals 0, we're going to make a note with this red dotted line that as we go off to infinity, we should approach but never touch the x-axis. So vertical asymptotes are easier. Vertical asymptotes occur where you have a divide by 0 problem. So if you were to plug in a -2 into that first parentheses, you get out 0 in the parentheses, and 0 times all that stuff makes 0. And if you were to plug in a 5 into the second parentheses, another asymptote. So we got to make a note at x equals -2, which is this vertical line right here. Oh gosh, it's a little bit better. We're going to approach but never touch, and at x equals 5, we'll approach but never touch. Another thing you can usually quickly get is the y-intercept, which is where the graph crosses the y-axis. And that's found simply by plugging in x equals 0. So if you plug in 0 into this, you get 0 on the top, and 0 plus 2 gives you 2, 0 minus 5 gives you -5, 2 times -5 gives you -10. So 0 divided by -10 gives you 0. We know our graph is going to cross here. And like up here, with this graph, it went to -infinity as we get closer to the asymptote, and then on the other side, it was the opposite direction. So you need to analyze what's going to happen with the graph as you approach it from the left, as you approach it from the right, as you approach this one from the left, and this one from the right. And you can do that with an idea called limits, but don't want to go into the idea of limits too much. We should do it this way. If you want to know whether you're going like this on the left side of this asymptote or going like this as you approach that asymptote, the asymptote's at x equals -2. So try plugging in x equals -3 maybe. And if you plug -3 into this function, you get -6 on top. And this gives you -1. This gives you -8. So you got a positive 8 down bottom. So -6 over -8 gives you a positive 6 over 8. Whoops, I messed up my mental math. This is actually a positive on the bottom because -1 times a -8 gives you a positive 8. So -6 over a positive 8 gives you -6/8. So -6/8, I mean, it's hard to graph, but we know it's somewhere down here. That leads you to believe that the asymptote is going like this, okay, because it's going to cross through that point. You can do the same thing on the other side. Get a number that's slightly to the right of that asymptote, like x equals -1. That's going to be a point that's a little bit to the right. That'll help us get an idea of what the graph looks like. So if you plug in a -1 into this function, you have a -2 on top. This gives you a positive 1. This gives you a -6. You get -2 over -6, which is a positive 1/3. So we know it's going to be positive coming from the right. And then as we keep going in our graph, we're going to have to remember we're going to cross at x equals 0 because that was the y-intercept we found. And you'll want to do the same as you approach this asymptote too. You want to find out if it's going up like that or if it's going down like that as you approach it. So to check that one, we could again plug in a number that's to the left of positive 5. So if you plug in positive 4 into your function, you get 6 and -1, those multiplied to be -6. So you get 8 over -6. That's a negative number, so that's how you know the graph's going to dip down there. So here's how we connect those two ideas. We knew it was going to be positive over here. It was going to cross the y-intercept of 0, and then we knew that our graph was going to be negative over here. So we made that asymptote happen. And then plug in like x equals 6. You get out a positive number. So that's what this side of the graph is going to look like. So that's it. Now we have a rough sketch of the graph. We were able to do it without a graphing calculator, but definitely not easy. So if you're allowed to use technology, you should definitely make use of that in your class for this type of problem.